Hello and welcome to this Java tutorial. So in this chapter, we'll go through methods in Java, some code examples of writing different types of methods and also recursive methods in Java. So coming to methods in Java, a method is a block of code designed to perform a specific task. Okay, so a method may or may not return a value after execution depending on its return type. And syntax of a method in Java is like this. The first thing, you will have access modifier, which may be public, private, protected, or default. Then the return type, if it is returning anything, then that type may be int, double, or some class also. Then you will have the name of the method. And if it takes some parameter, then that parameter list. Then curly braces, within that the body of method. So whatever is written within these curly braces becomes the method block. That is the logic of this method. So let's start with some background on why do we need methods, then we'll come again to the syntax properly. If you see, so far we have been writing all our code inside main method, right? So while this works for small programs, as the project and its code base grows in size and complexity, it quickly becomes difficult to manage. So a better approach is what? Break the logic into smaller reusable methods. Splitting code by functionality makes it easier to read and debug and also improves its modularity and long-term maintenance. So suppose you have a class with 100 lines of code written entirely in one method, right? All your code written in one method only, all 100 lines. So debugging such a method block is difficult, right? Because every error forces you to scan through the entire method. You have to go through the entire method. Now suppose you split that logic into 5 methods of 20 lines each. Now if an error occurs, you can quickly isolate it to the specific method rather than combing through all 100 lines. So that is why you should start practicing this modular approach of splitting code into different methods. As we saw, right, that improves your modularity, readability. So you can think of a class like this. Okay, so suppose you have a class test which has these separate methods. Okay, now suppose you get error here in method D. Then you know that code is having problem within this method. So you have to look within this for the problem, not in this whole class. If you have everything written within one method, then you have to go through everything. Now you can isolate your error to this method. That's what you mean by making it more readable and modular and easy to debug. So let's see how this code division starts from the top in a project. It's not only methods, but from the very top, you start dividing your project code functionality into different parts. So in a large Java project, first division is through the modules, where code is organized into modules based on functionality that defines clear boundaries and dependencies. So this ensures that different parts of the system remain independent yet connected. For example, if there is a project to automate the working of a whole company, then you may break it into modules like you may have employee management, one module, housekeeping management, another module, admin, account, and many more such modules. Then within each module, code is further grouped into packages. So packages bring together related functionality, making the code base easier to navigate. So this image shows the same thing. So for example, within the employee management module, right, you may have packages for employee joining, employee leaving, employee tracking. So you may have different packages like that, covering one part of the functionality. Now within these packages, you will have classes. These classes will encapsulate data and behavior. So for example, in the employee joining package, you may have classes like employee details, joining form, probation period calculation, right? So classes like that. And in employee tracking package, you may have classes like employee timekeeper, employee leaves, and so on. all tracking related, right? So you group classes based on functionality within packages and a broader functionality within modules. Now within these classes, you break down your code into methods, each handling a specific task. So these methods keep your logic modular, reusable, and easy to debug. So for example, in the employee detail class, you may have methods like add employee, validate employee data, generate employee ID, right? Which handle distinct responsibility. And in employee timekeeper class, you may have methods like capture in time, capture out time. So you may have a class like this, employee timekeeper, where you may have different methods, right? You can divide your functionality of this class into separate methods. One method to capture in time of the employee, one method to capture the out time of the employee. Then you may have some other methods also to calculate average week hours of the employee. You may print the weekly report of in and out time. All that you can bring in one class, all the functionality about timekeeping of the employee, and that you can write in separate methods like this. So that's how you have to start thinking, how you can break your code into class, and within that class also how you can break it into separate methods. So for now, you will learn how to split the code into different methods within the class. So we'll start with the lowest in this hierarchy, this part, methods. Once we have this background, let's go back into the syntax. What we have seen is you have a syntax like this, right? So let's go through the different component in this syntax. The first thing is access modifier. So it may be public, which means your method is accessible from all the different classes. If it is private, means accessible only within the same class where it is written, there only it can be used. Nowhere else you can call it. Protected means accessible within the same package and by subclasses which are even in different packages. So that involves some inheritance also through subclasses. And then there is default. If you don't give any modifier with the method, then it is accessible only within the same package. So any other class within the same package that can access your method. Then it has return type. So that specifies the type of value a method returns. So if your method returns int, then your return type will be int. If it returns double, then double, right? Or if it returns some object of a class, then your type will be that class. So suppose I have a person class and my method returns object of type person, then return type will be person. And it may not return any value also. So your method may not return any value. It is not always required that it has to return a value. In that case, return type will be void. You still have to give void as return type. Then see, we have access modifier, return type. Then we have method name and parameter list. Method name is the name of the method. Then we have parameter list, which are the inputs passed to the method enclosed in parentheses. You may give some inputs also to the method. And that is not always required. If there are no parameters, then also you have to give empty parentheses. Then you have method body within these curly braces. That is code of your method, logic of your method. Then it may also have exceptions. So that part, let's not go into this right now. Okay, so that is the syntax of your method, the different components in your methods. Now, using all this, that is how you can declare some method. So here is an example where we have a public method, which has two parameters which are of type int and also return a value of type int. So since it is public, so first thing is access specifier, which is public, then return type. Since it is returning, if you see value of sum, which is of type int, return type will be int. Then name of the method, and it takes two parameters of type int, which means when you call this method, you have to pass two values of type int. Okay, then curly braces and the logic of this method. So that's how you can write a method. We'll just write it ourselves also. One more thing is naming convention for method. When you write a name of a method, should follow this convention. If it is a single word, then it should be in all lowercase, like this add, print. If it is a multi-word name, then it should follow camel case. If your name is like this method name, get final data, then camel case means first word should be all lowercase. Second word onward, first letter capitalized. Here also, if you see do addition, do all small case, addition first letter capitalized. So this you should follow. It's a convention, not a rule. So if you don't follow, you won't get any error. But in a big team, everybody follows these convention for readability and consistency purposes. You should also follow. Otherwise, your code will stand out as badly written code. Okay. So follow these conventions. With that, let's go to writing some examples. So when a method is called, it executes method body and returns to the point from where it was called. So it will go back to from where it was called. So there is a calling method and called method. Two things are there. We'll go to that. And when will it do that? Once it completes all the statements in the method, then it will go back to the point from where it was called, or when it reaches a return statement or some exception occurred. Okay, so three scenarios are there when it will go back to the point from where it was called. Now let's see first thing, when your method is returning a value. In that case, how will you write that method? So we'll write within basics only. Suppose I create a class named my class. All right. So this is our basic structure. Now what we have to do is we don't have to write our logic within main method. What we'll do is we'll write a separate method. Let's say public int do addition, which takes two parameters, int I, int a. What we are going to do is sum of these two values. So what we can do is int sum equal to I plus j. Then we have to return this sum. So return keyword is used for that, return sum. Okay, so this is our method. What it is doing is it is public, so it can be called from anywhere. It returns a int value, right? Sum, which is of type int. That is why return type is int. Then method name do addition, which takes two parameters because we have to sum two values. That is why two parameters. When we are going to call this method, we'll pass two values and it will return this sum. Now, in order to call this method, what we have to do is we need to create an object of this class. That we have not done that part, but it is not very difficult. So what you have to do is my class, some variable equal to new my class. That is how you can create a object of this class, and using that you can call this method. So we have to pass two values here, right? Let's say 6 and 8. So 6 will be passed to I, 8 will be passed to j. I will have value 6, j will have value 8. When you do I plus j, that is 6 plus 8, that becomes the value of sum 14. That is what you return, right? If I run it right now, it won't return anything, right? You see, I won't get any value because what we are doing is we are just returning it, but where we are printing, correct, right? This value is returned. Now let's understand that point. So this is the calling of the method, right? That's where you are calling this method from this method, main method. So this is the calling method. This is the called method, right? So calling method is main, called method is do addition. And once it gets this return statement, it will return to the point from where it is called. So it will come back to this line 7 with this value sum. But where are we taking that value? So we have to take this value somewhere. So that is done like this. So 14 is returned, which is assigned to this sum. Now if you see, we have two variable of the same name here and here, sum, and we still don't get any error because they are local variable to these methods. That's what you mean by local variable. This sum is having scope within this, right, main method from here to here. This sum method has scope from here to here. Once we come to line 10, this sum method does not exist anymore. That is why you can give this sum variable name here also. So these are local variables. Now, actually, once we have this sum, do sum is plus sum. Then we'll get the value. So that is the flow of the method. One more thing is about parameters. As we have seen, it needs two parameters. So we have to give two parameters here with type. So both are int. That means we can pass only int value. If I try to pass any other value, we'll get an error that I'm trying to pass double and int, and what it needs is int and int. So you have to pass the correct parameter. If you need to do some of decimal values also, number with decimal, then we should make this also double actually. So double int I, double j, then this will also be double. What it returns is also double, and this also should be double. Then we can pass double values also, 6.8 and let's say 13.4, which is 20.2. Correct. So this is your method which returns a value using return keyword. Now suppose a method which does not return a value. So suppose I have to display greeting also. I can have a method public display greeting. So it gets a name. Name means it should be of type string. So name, and it just displays that, right, greeting using that name. Now since it is not returning any value, right, it here it does not make any sense also to return any value. It has done its work. In that case, you can give void that this method does not return any value. So I can call this also object dot display greeting. I have to pass some name. Right, so this is a method with no return type. Now you may also have method in another class which you call from different class. So that is also possible, and that is what you will actually do if you are working in a big project, right? You will have many classes, and from one class you will call method of another class. That's how you'll have communication between classes. So you'll create some dependencies. Suppose I create one more class. Let's name it calculator. And here I have a method public. Let's say we'll take double only. Multiply. We can multiply two values, double A, double B. Right? Curly braces. Return A into B. I can directly return. Here in sum, I've taken a variable and then returned just to show. Here, if you see, that's how you'll actually do. Why create one more variable? Return A into B. Okay, so main thing here is now I want to call this method of this calculator class from here. from my class. So first thing you have to create object of calculator class here. Calculator, calculator equal to new calculator. Using that, I can then call calculator dot multiply, and I have to pass two values, 5 and 6. Here again, I have to take that in some variable, then I can print it. Multiplication is plus number, right? So 30.0. What we have done is we have method here in this class, multiply. We are calling it from here in my class. So we have to create object of calculator. That's what we are doing. We are creating a dependency here on calculator. So my class depends on calculator class to do some of the work. Then we call method of this class. Here it is public, so we can call it from any other class. So it can be called here. So that is also and a very common thing. That's what you will do in your big project. You'll have many classes and you will call method of one class in another class, or many methods of many different classes in one class. Then calling one method from another. So within same class also you can do. So if we take this only, right, display greeting. Suppose we have to get name through separate method. What we'll do is, suppose we have a separate, we'll remove this name here, and here also we'll call like this, and we'll have one more method which is here only, so we can make it private also. Private will return a string, get name. So in reality you may have to go to database to get name. Here we'll just hard code return, then we can call it here. So we'll take it in this and get name. So we call from here display greeting, it comes here. From here to get name, it calls this method get name, gets the name, come back here, prints this value, then goes back here. So that is your flow. Then it will do this work. That is why it is coming here. So I can call method within a method. So these are some types of methods you can say, or different flows which you will use in your code. So now let's talk about one of the special type of method, which is recursive method. So recursive method actually is a method that calls itself to solve a problem. So you will recursively call the same method again and again. So if you have some problem that can be broken down into smaller similar subproblems, so you have to call the same method again and again with some smaller number, right, or smaller unit, then you can use recursive method. So coding problems such as if you have to get factorial or Fibonacci series or reversing a string, all that you can do with recursive methods. So some key points about recursive method: it should always have a base case when it has to come out of the recursion. Otherwise, you'll get into an infinite recursion and you'll never be able to come out. So once stack is full, then you will get an error and it will come out. So you should always have a base case. Then you have a recursive case where you call the same method again with a smaller or simpler input. You try to go down with each call. Go down means come to the base case so that you can come out of that recursion. So each recursive call is also pushed onto the call stack until the base case is reached. So it uses this stack data structure, right? Whenever you use any method or you do a method call, actually that goes into a stack. Let's see it with this example, right? So suppose you have to write the code of factorial. That is how you can write it with recursion. So you call the same thing again and again. Why you can use recursion here? Because if you see, right, factorial of 5 is 5, then you keep multiplying with one smaller number, right? So you have a similar problem with smaller input. Every time you can call the same thing. And if you have to visualize it, you are calling the same method. So first time method will be called with 5, right? This is one stack. Now on top of that, another call with 4. On top of that, another call with 3. Another call with 2. Then with 1. That's when you will come out. Then you will start calling these stacks. So last in, first out, right? LIFO. So it will first call this first one. 1 into 2 into 3 into 4 into 5. That's how you'll go. So code I have already written for this. So that is your recursive case, right? What you are doing is, suppose I'm calling with 5. So factorial of 5. N will have value 5. Then what you are doing is 5 into n minus 1, 4. So you are calling again this method with 4. Then what you will get, 4 into 3. 3 into 2. 2 into 1. Then you will come out. If you see, result will be 120. So this is your recursive call. You are calling this method again with a smaller value. You can also debug it to see same thing. You can also debug as, when you do run as, you run the Java application, debug as Java application. So it will go to the debug perspective. Yes, switch. And you can call it. So first call, if you see here, n is 5 right now. If I press F5, it will go to the next call. Now n is 4. It is calling the same thing with 4. And it also checks, is it less than equal to 1? Not yet. Now n is 3, right? Here you can see. Then I call it again 2, then 1, then it will come out, right? Return 1. Then it will start unwinding. Now if you see, it will start increasing. And 2, then, and factorial returned 2. Now n is 3. With that, it will return 6. And now n is 4. Now it is 24 is returned, n is 5, and you get 120, and your code is done. You have the result now, which you can print. This process, you can understand it like this also. So factorial 5 needs result of factorial 4, that pushes factorial 5. Then factorial 4 needs 3, pushes 4, 3 needs 2, pushes into the stack 3, and so on. Then you start unwinding. So factorial 1 returns 1, 2 returns 2 into 1, 3 into 2, 4 into 6, 5 into 24. That's how you get the final output. So there are some problems, as we saw some examples here, factorial, Fibonacci series, reversing a string, which you can do with recursion. It is simpler done with recursion. So it looks a little complex in the beginning. But if you see implementation wise, it is simpler. Okay, so time to do some exercises. So for methods, we can do these 3 programs for practice. So suppose we take this one, write a class calculator which has following methods: sum, subtract, multiply, division. So we already started writing a calculator class, right? Let's go to that only. And though there it says int, let's do with double itself. So we have this multiplication already done. In fact, addition also is done here. We can bring that itself here. Multiply, let's name it like this only. Every multiplication, addition, double I, double J, return, then We can have for subtraction public double double I double A return I minus J and public double division double I double J return I slash J. So that's how we can write all the method. Let's call it from here itself. Use from itself calculator dot subtraction. Let's say 15 and 6. Subtraction is this. Then let's take this again. This time division. Division is so multiplication 5 into 6 30, subtraction 15 minus 6 9, 15 divided by 6 2.5. So that's how we can create a separate class. And one thing, if you have to notice, right, we don't have a main method here because it is not needed. This class is having a main method and this is the starting class, so is okay. From here itself we can call this class and do the work. So here we don't need main method. Main method should be in one class only. If you are going through several classes, right, so only one of the class will have main method, then you can go across all the other classes. There you don't need main method. Then we have another one, write a program with method average that takes 4 parameters and return the average of those 4 parameters. So I think you should do it yourself. It is very simple. 4 parameters, pass those values plus division by 4, right? Then we have to display Fibonacci series using both recursive and iterative methods. If you don't know Fibonacci series, it is a series of natural numbers where next number is equivalent to the sum of previous two numbers. So every number n is a sum of previous two numbers, n minus 1 and minus 2. Right? So this one is sum of 1 plus 0. This 2 is sum of 1 plus 1. This 3 is sum of 2 plus 1. So this can be done using recursion also. And you can do it using iteration also. We'll need a loop here, which we have not done, but we'll manage. New class. Okay. And we'll take some. I need first 10 numbers. So num equal to 10. Then I'll have a method. It won't return anything. I'll display here itself. Void in iterative. Let's first write it iterative. So it will get this number. So what we have to do here is we have to take two numbers, then sum it to get the third number. And every time we have to slide also. Then these two, right? To get the sum. Then these two, we are sliding by one also. Next time, we have to take these two. Next time, these two. To write logic also using that. Let's say int num1 equal to 0. Int num2 equal to 1. And we have num3 also. Then we can take int I equal to 0. So I'm using a for loop which will do the same thing again and again in the loop. We want to print it, let's say it is 0. First I'll print it. Num3 3, and I'll give some space. Then what you can do is now 1 will have value of num2. You have to shift also, right? Num2 will have num3. Num3 will be a sum of these two, num1 plus num2. That is how you can easily remember the logic. You have to call it, right? For that, I have to create a object also with this num. We get 0, 1, 1, 2, 3, 5, 8, 13, 21, 34. Let's remove this ln. So we get them in same line. Print line means it will get it in next line next time. We've already given space. That looks more, right? So 0 plus 1, 1, 1 plus 1, 2, 2 plus 1, 3, 5 plus 8, 13, 13, 21, 21, 13, 34. Correct, right? So remember it like that. We have to shift, and this is the sum of previous two numbers. This is iterative approach. Now, if we have to use the recursive approach, let's take this itself and change this to recursive. Now, so first thing is base case. So if it is 0 or 1, that is our base case. If num is less than equal to 1, then return num itself, 0 or 1. So in this case, we'll get. Otherwise, what we'll do is we'll call this Fibonacci recursive itself, Fibonacci recursive with previous two numbers, right? So num minus 1 plus Fibonacci recursive num minus 2. And that is what will return. So one way is to use this object way, or what you can do is you can make it static. Then you can directly call. For this also, actually, you'll use this loop. For int I equal to 0, I less than num I plus plus. Within that, I can call this Fibonacci recursive with the number. Okay, so Fibonacci recursive, when it is 0 or 1, it will return this only. For other, it will return this. We have to print also, right? So we can do here also sys out. And within this, I'll bring this plus, I'll give space here itself and remove this. We get in same line, right? Okay, so everything is coming in one line itself. So here I should give one line in between, and here I'll write recursive output so that a distinction. So this is iterative, then you have recursive output, which also is same thing. Or if we make it, let's say 15, then we get the 15 numbers, right? 34 plus 21, 55. 55 plus 34, 89. 89 and 55, 144. Correct only, right? Let's see if it works for 0 properly. We don't get anything for 0. For 1 also, you just get 0. 2, we get 0 and 1. Two numbers, first two numbers. All right, so that's how we can do this. Uses this for loop also, but I hope you got the sense of why we are using this loop to do the same thing again and again. So that's how we have done some exercises also for methods. I hope that is making sense now. And from now on, it is expected that you will start thinking in terms of methods in a class and how you can break the functionality into separate methods rather than writing everything within the main method, a lot of code within main method. That is not acceptable. You start breaking your functionality into smaller methods. Thanks for watching the video. Please don't forget to like and subscribe.